Hello and welcome to University of Manchester, the birthplace of chemical engineering. I'm sure you must have heard of it before. My name is Dr. Salman Shahid, and I will be delivering this unit on process fluid flow. So the University of Manchester is one of the best places in the UK to study chemical engineering. And I'm not saying that because I work here, but actually it's the other way around. I work here because it's one of the best institutions in chemical engineering with very high employability rate. What it means is that a lot of our graduates get jobs right away after graduation and even before graduation sometimes. So you have a good prospects and bright future ahead of you, but you have to put the effort and work hard to get there. So this is very briefly about our university and that you will get to know more and more in the coming days. So the university is very interesting experience of your life. You will learn a lot. You will get to meet new people and you will build friendships which last for your whole life. So in addition to learning, do build these friendships here as well. So before going into detail of this unit and what will be our teaching methodology for this unit, I would like to formally introduce myself. So my name is Dr. Saman Shahid. I'm a lecturer at chemical engineering, and my background is that mainly I am basically I'm a chemical engineer, and I did most of my studies in Europe where I work on development of smart membrane materials for water separation or water treatment. And here, just to give you a very brief overview of that. So I'm generating these smart membrane filters that you can actually use electricity to manipulate their behavior as a filter. In addition to that, I have several years of experience as a process working as a process engineer in a utility system, dealing with the pipings and the pumps and all these boilers and condenser design. Um, and I also have several years of experience as a teacher. I worked 4 years as a lecturer at University of Bath, and I recently joined University of Manchester in March 2022. I have several certifications of professional teaching excellence, and currently I'm acting in teaching and research supervision. I will be teaching this course with my colleague, Dr. Tom Rogers, who is again basically a chemical engineer and have several years of experience as a professional engineer in several big industries in personal care, food, and commodity chemicals, mostly dealing with fluid mechanics. And he joined University of Manchester in 2013, and he recently finished his role as a head of education, and he also has several teaching excellence certificates as well. So this unit can be divided into two main sections. So I will be teaching the first half of this unit with some fundamental concepts, and then Dr. Tom will take over and then deliver some of the more engineering related concepts and energy conservation models. And finally, I will have last lecture on open channel flows. So what we will cover in this unit, we will, again, as I said before, we will discuss some fundamental definitions of fluids and fluid mechanics. We will look at different properties of fluids and how actually we can calculate the pressures of a fluid at rest and in moving conditions in pipes, for example, and how we can use the velocity to classify these fluids, for example, by using Reynolds numbers that we will discuss in the coming lectures. Then we will also look at conservation of mass, that is continuity equation, and conservation of energy, that is called Bernoulli equations, and how we will use these two principles to measure the flows of fluid in pipes and the pressure losses in pipes and fittings, for example. We will also look at different types of pumps and how we can actually select a pump for a specific flow rate in industry. And finally, we will look at what is the flow in open channels and how it is different from, for example, flow in pipes. So open channels are, for example, rivers, dams, and canals. So how they are different from fluid flowing in a pipe. So by the end of this unit, you should be able to describe different types of fluids and their properties. You should be able to distinguish between hydrostatics and hydrodynamics, that is, fluids at rest and fluids in motion, and how we can use fluid mechanics principles to measure the pressure, how we can classify fluids with their velocity, how we can apply mass and energy balance to calculate the flow and the pressure losses and energy losses in a piping system. And finally, you should be able to classify pumps and use the basic principles to select a pump for a given job in industry. In terms of teaching, we will be using a blended learning approach. So what it is, it's a mix of online and in-person teaching technique. So you will have a pre-recorded lecture available to you on Blackboard in the form of pre-recorded videos and lecture slides that you need to review before coming to the lecture. And in lecture, we will perform some tutorial and exercises where we will practice the concepts, engineering concepts in the form of problems. So I will be there to help you, and there will be also several PhD students, what we call ZTAs, that will be there to help you find the solution to the problems. And then you can also use a tool that we call discussion board that is available to you via Blackboard, where you can actually put your questions, and I will be monitoring that and answer your questions, but it is mainly for you to interact with your peers and within your class. I have also generated a Padlet page. Again, it can be used for posting your questions and the concepts that are not clear, so that I can answer those questions and those concepts in the class, or I can revise those concepts that are not clear in the next classes. There are two main sessions that are for your timetable. So we have asynchronous sessions that are where you can actually view the material in the form of pre-recorded lectures and slides in your own time, and that is actually before coming to the class, and you are expected to dedicate at least 2 hours a week. And then you have synchronous sessions that are actually mean you have in-person tutorial sessions where we will practice the concepts that we learn in these pre-recorded lectures. And these sessions are designated in your timetable, so it's easy to remember. In terms of reading material for this unit, so because it's a very broad topic that comes under chemical engineering, civil engineering, mechanical engineering, electrical engineering, so this topic is very kind of fundamental topic in all engineering degrees. So we have a range of books that we can use for it, but mainly we will be using the book called Fluid Flow for Chemical Engineers, and this is available online through the library, so you don't have to buy any of these books. They are mostly available. And in addition to the main core textbook, we will also using several additional books, and time to time we will take some topics from these books, and then on the slides I will notify you that which material is taken from what book, so you can review it. In terms of your assessment, so you will have one mini exam that will be in week 4, and that will we will cover the material that in this exam that is delivered in the first 2 weeks of the course, and that will account for 20% of your final grade. And then you will have end of term exam that will be in January and will count for 80% of your final grade. So the plan, in addition to these two summative assessments, you will have plenty of formative assessments. These are in the form of quiz and tutorials, where actually you can test your knowledge, and this is mainly for you to know, to judge the level of your understanding, if you're getting the concepts right or wrong. In terms of my style of teaching, I really encourage you. I would really like that if you ask me as many questions as possible, so that you can clarify your concepts. And I would really like you to look at these two quotes from Confucius. So I hear, I forget, I see, and I remember, I do, and I understand. So this is really important for engineers, that you need to practice the concepts that you learn. You need to do the problems to really understand the concept. And the second thing that I really like about this quote is that it does not matter how slowly you go, as long as you do not stop. So it is also important that you review your material on weekly basis, so that you can actually build those concepts in time, because it takes time for those concepts to kind of solidify. So you need time. So it is important that you review your material on weekly basis and do not leave it for the end. And with that, I just want to say I hope you enjoyed this course. And if you have any questions, please do not hesitate to contact me or Dr. Tom, and we will be happy to answer your questions. And I hope you enjoy this course. Thank you.